Drawing Lewis dot structures is especially important if you're going into organic chemistry or inorganic chemistry, or if you're going into a part of biology that looks at the processes that happen on a molecular scale in the body. All of those rely on understanding how molecules look. Now, we can't really see these molecules as we're drawing them because, of course, we have letters in them and molecules don't have letters and stuff. But this is our representation of the molecule. This is how you will see pictures of the molecules if you ever read journal articles about them. So it's important for everyone to be on the same page. Often students really like this section too because it's very visual and it's a nice change. So the first thing you're going to do is add the total number of valence electrons. Those are the outermost electrons. We've already practiced doing that. So remember, if it has a charge, you're going to have to kind of change it up. If it's neutral, you just add up the valence electrons. But if you have something that's negative, like NO3 minus, that counts as an electron. You'll have to add an electron to your count. And then remember, if you have NH4 plus, you're going to remove an electron. So don't forget that little trick. We already talked about that also. I always like to put a big old box around it. So for example, if we have CF4, and we've already done this one in a previous section, but carbon S4, fluorine has 7 times 4, which is 28. So this is the total of 32 electrons. This is what I like to box so I don't lose track of it. Write down the least electronegative element. Now this could also say the least electron affinitive, but if these words are words you've forgotten, it's okay. Never fear, the periodic chart is on its way to save you. You're looking to put the element that's away from this part of the chart first. So, and as the central atom. Usually it is the first element. So for example, in this case, carbon is located here and fluorine is over here. So carbon is more to the left, so it's the least electronegative element. So obviously, normally it is the first element that's going to be written as the center. If you have a confusing situation, you'll have to be told. But there is one element that will be written first, but it can't be the center, such as in water, H2O. Hydrogen's written first, but it isn't the center. Why not? Think of its size. Think of how many electrons it can have. Only 2 electrons. So if you can only have 2 electrons, that means you can make one bond. So you can't be in the center of something if you can only make one bond. You'd have to be able to make tons of bonds to be in the middle. So hydrogens are always on the outside. Always, always, always. Hydrogens are always on the outside. So carbon, the right one is written down. Write the other elements around it evenly spaced, drawing those lines showing that the lines represent bonds. Each line represents 2 shared electrons. This is a single bond, so that'd have 2 electrons. We won't do them yet, but double bonds have a total of 4 because there's 2 in each line, and triple bonds have a total of 6. Again, there's more on that coming up. So we're just going to do this, 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 and this. Be aware that we will be talking about what the structures really look like, so drawing them very beautifully like this, where they're perfectly across from each other, that might change a little bit coming on the future. And this one especially will change, but for Lewis dot, this is perfectly acceptable. So this element has a total of 2, 4, 6, 8 electrons already used up. So just so that you know, 8 are used, so I only have 24 left. So I'm going to put the electrons right now, fluorine has 2, but he's supposed to have 8 around him. So that's the case for all of them. So I'm going to see if my other 24 add up to make the right number. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Another way you can do this also is that if you are positive that every element has its 8 around it, so this is a group of 8, this is a group of 8, this is a group of 8, and this is a group of 8, so 8 times 4 is 32. Because all of these are going to be having 8 electrons around them, except for hydrogen. Remember, hydrogen can only have 2, so if you have hydrogen on the outside, that won't work. As long as your electron count matches that 32, you're good and you're done. What's left, though, is that sometimes it doesn't match. So that's what's going to be coming up, is dealing with the times that it doesn't match. So right here, we're going to deal with something that doesn't match. And this is actually in the next chapter, but you're going to then move on and you're going to name the geometry, and you'll even look for things like resonance and formal charge.